A fingerprint consists of data points called minutiae. These data points are defined by their x and y coordinates and are relative to each other. A fingerprint template may often contain data points where the fingerprint ridge either terminates or bifurcates. When a user presents their finger in a biometric system, the minutiae is extracted from the finger and then matched to the user's template. The system will then need to decide if the user can be authenticated or not. The balance between a system being highly secure versus highly convenient is based on how precise the matching process is defined. As you can see, the success of a system is based on the quantity and integrity of the extracted minutiae. Semiconductor or capacitive sensors are common in the consumer marketplace as they are an inexpensive biometric sensor for the OEMs to integrate into their products. Unfortunately, these capacitive-based sensors are difficult to use, they are unreliable, and they easily break. The next type of fingerprint biometric technology is an optical sensor. Optical sensors are more robust than capacitive-based sensors. An optical sensor shines light on the glass and scans the surface like a copy machine to extrapolate the minutiae. Even though these types of sensors are more robust, they are still susceptible to conditions that deviate from a controlled environment, meaning they fail when a finger is too wet, or too dry, or too dirty. These are common conditions found in the real world. There is a solution to poor fingerprint biometrics. Introducing multispectral imaging technology. Although MSI is optically based, we do not act like a copy machine. Our patented process of extracting the user's minutiae works by shining multiple wavelengths of light into the finger. These wavelengths of light reflect back to the imager where we reconstruct the raw images to reveal your biometric signature. Our more effective solution is based on using multiple spectrums of light and advanced polarization techniques to extract unique fingerprint characteristics from both the surface and the subsurface of the skin. The nature of human skin physiology is such that this subsurface information is both relevant to fingerprint capture and unaffected by surface wear and other environmental factors. When you evaluate all of these technologies in real-world conditions, it's easy to see why the world of biometrics has such a poor reputation. For example, when you look at the optical sensor image where water is present, the captured image is completely unusable to a biometric system, as zero minutiae points can be determined. Multispectral imaging works in all of these conditions and will provide a great image for the template matching process. With MSI, the weakest link is no longer the biometric sensor. Near-field communication is positioning to be the next Bluetooth, but on a much grander scale. With mega companies like Google, ISIS, Visa and Apple incorporating NFC into mobile devices, NFC will be the enabling factor for how consumers communicate to the world and to each other. People will no longer need their keys for their home, for their work, or for their car. They will be able to check in at the airport and pay for merchandise and services without even carrying their wallet. Travelers will be able to check into their hotel and access their room without even going to the front desk. So what role does MSI have in this new world? There are 3 factors of authentication based on what you have, what you know, and who you are. All implementations of authentication should include at least 2 of the 3. Traditionally, a card or fob along with a PIN was accepted as the way to do business, but the world has PIN fatigue. Consumers simply cannot remember every code for all of their secure information. So, by eliminating what you know and focusing on what you have and who you are, we now get a perfect formula with NFC and multispectral imaging. This dynamic duo will become ubiquitous from both the convenience and security that they provide. For more information on anything that you have viewed in this presentation, please do not hesitate to call